everyone. We're going to get started now. Thanks for joining us today. And my name's John Petze. And in this session, we're going to talk about how we can use the new data analytic tools. What we want to do is talk about the overall concept of data, how we use data, and how the new tools that work with data help us. So let's get started here, the role of data in the whole process, right? It's really the fundamental element we have to work with when we're doing commissioning, right, or M&B. And what we're seeing is more and more sources of that data, right? Where we can get that data, the data involved in projects, I think you could argue it's exploding from all of the different sources of data. Now we can say we're going to ignore some of it, not use it, but let's see how we can take advantage of more and more of it with tools that enable us to do that. We've got our building automation systems, a variety of brands. We've got metering devices. We've got APIs that'll allow us to get data from utility companies in better ways than we have been able to before. Of course, we've got rate data that can dramatically affect how we can deliver financial results for end users, and of course, weather data. And we get too much data, right? Or we've got more than we can deal with just as human beings. So we really need tools, right? And that's what analytics are. They are a tool to work with data. So let's talk about that. The role of analytics is simply to enable us to automate the process involved in working with data, from getting the data, to storing the data, to analyzing the data and reporting it out. Can you do every one of these steps manually? You can, but you can't do it cost effectively, you can't do it efficiently, you can't scale. We need tools. So let's start here. The traditional approaches used are typically, manually collect data, manually interpret it, use our, deep experience, professional experience. We look at pictures and graphics and charts from BAS systems. We import data into Excel. We manually assemble reports in Word or other reporting tools. And typically there's not one tool to do all this. We end up using lots of different tools. So if we want to apply analytic tools to it, how do we look at the problem, right? Well, the first problem we look at is let's identify and then get the data from our systems, right? We want to connect to the available data. And this brings out one of the first points is available data doesn't mean it's live data, doesn't mean it's streaming data. It means what can I get my hands on? Good example might be that you might have someone who has years of interval meter data in Excel. That's useful data. How do we connect to it? I go over with a thumb drive and he gives it to me. That's a data connection, right? Okay. But I may want to connect to building automation systems, et cetera. Okay, and once we get the data, we have to store it, and ideally we want to put it in one place, one database, one normalized form, so we can do all of the different things we need to with a single tool and a single process. And then the result should be that we're going to calculate KPIs, key performance indicators. We're going to identify faults, deviations, anomalies, issues, correlations, et cetera. So the process starts with acquiring data, and there's many factors involved. There unfortunately isn't only one way, right? You may want to connect and may be able to connect to streaming data out of a building automation system. And I say maybe because a lot of times there's a lot of barriers to that. Okay, it might be a proprietary system or it isn't open. And we see many cases where it's an open system, but there's all kinds of security barriers to even get the data, right? But we need to think beyond just getting live data, right? Oftentimes you have to start with batch import of data, CSV files, access a SQL database that already has collected the data. Why duplicate that work if it's there? Okay, well, how do you do that, right? Again, software tools to enable to do that, right? But there's lots of protocols out there. Probably BACNet's the most deployed one, but there's others, Modbus, OPC, OBIX, the new Haystack protocol, et cetera. So part of the role of software is to automate connecting to and getting the data in, whether it's batch or live, right? But the next step is really kind of where the work is and often unseen, which is how do we normalize that data into a uniform format that we can work with effectively with our tools without having to do everything separate or different, right? This data from these different systems comes from different sources. It comes in different formats. Some formats are well structured, some are completely unstructured. The term is multi-structured data. right? And if we're going to do analysis of our data, we need to know some things about it. The data has to be normalized in some fashion or form, right? And oftentimes we kind of do this in our brain if we're doing it manually, but that we have to move beyond that. And this is really one of the most important parts of the process of using these new software tools, analytic tools in our commissioning and M&B work is the process of normalization. So I want to spend a little time talking about that topic. Okay. So the concept of normalizing the data and making it useful really boils down to what we call giving the data meaning, right? The data has to have some meaning so that we can interpret it, and we can use software tools to automatically interpret it. And I use a simple example to try to get this point across, right? That we want to add descriptors, we'll call them tags, right, to our data to describe the attributes, the meaning, the facts about the data. So let's just go through a quick example, right? That one's out of order. Here's an example, right? So you say to me, hey, we got some data, I can connect to this system, and I connected to it, and here's what I got. I read this record in the system. It has this crazy cryptic 12-character name. Okay, great. Right? I don't have I have a legend. What does the name mean? I don't know. Oh, but there's a number associated with it. I've got data. You get some text data, get numerical data. Now what do I do? Right? 76.2 is a number, but what does that number mean? Right? And I think one of the things we often overlook as human beings is numbers typically come around with a unit, so we know what they mean. Without the units, it's interesting to say, numbers actually have no meaning without units, right? Get my cohort over there. Paul, I'm going to give you 100. What? Okay? Not dollars, okay? All right. So we see numbers have units. Now we have some meaning. Let's say the units are degrees Fahrenheit. We know a little bit more about that piece of data. But what is it measuring, right? Maybe it's just room temperature, late in the afternoon, you got a boring speaker, 76 degrees, might start falling asleep, right? Maybe it's the return air temperature. It's like, wow, right on the money, right? So what is it? We can say it's a zone temperature, degrees Fahrenheit. I got 3 pieces of information that describe this, right? But if I want to make an interpretation about that, what do I need? I need some more information, all right? What's the schedule for the space it's serving? Because you know what, a night setback, no problem. Everybody's in here, problem, okay? And that's another piece of data, but it's a different type. It's called an association. This value is associated with this schedule. Together they have meaning. Alone there don't have as much meaning, right? You might want to know what air handler is serving it, okay? What VAV box is it coming out of, et cetera. These are all descriptors. These are all pieces of information. And the question is, when we're pulling data together from all these different sources, all these different systems, it's multi-structured data, how are we going to convey these answers in a standardized form, okay? And so what I want to talk to you about is an effort to do that, an open source effort, nonprofit, open source 501c organization started back in 2011 called Project Haystack. And the focus of that organization is to solve this problem, which is how do we normalize and standardize the way we put descriptors on data so that if I get data from you, it's got the descriptors, I can read it. More importantly, my software can automatically read it and do things. That's what Project Haystack's about. How many people have heard about Project Haystack before walking in this room? Okay, not bad, but not enough. Okay, all right. And people say, well, tell me about what is Project Haystack, because it's core to this whole thing of how we're going to work with this overwhelming volume of data we have. And well, the first thing it was a community of people got together and says, we got to solve this, okay? We got to solve this challenge, which is that the device data I get actually has very poor or limited or, in more cases than you'd believe, no descriptors, maybe other than a unit, right? And we need to come up with a better way to solve this, because otherwise lots of manual labor, right? And if you want to sell a commissioning project to an owner, the amount of labor going into that is a key part of whether it's going to get sold or you're going to make any money, right? This manual effort is a huge burden and barrier to our industry. So a bunch of people got together and launched this effort, okay? And what it does is it's created a standardized approach, open source approach. And the way I like to describe it is, think of it as a markup language, right? Okay. Somebody in here, I'm sure everybody's company has a website, right? I hope that's the case, okay? If I get my computer and go to your website, and I can read what you got on your website. That's like pretty amazing, right? Because you and I didn't pre-organize it, right? We didn't get together and say, I'm going to want to read that stuff, so tell me how your data is formatted. Don't have to. Your data is formatted with an open source standard called HTML. It's been around for a long time. We probably forget most about it, but before that, everybody's website would be unique, right? But of course, this started at the very beginning, right? Well, think of Project Haystack. It's the same thing, but for the data that comes out of devices, equipment, systems, et cetera, right? Standardized way, we're all going to mark up our data. So if I connect to your data, I can read it because it's got descriptors. We call them tags, okay? And this is really fundamental. Again, it's open source, used in thousands of applications, literally around the world. So it's a very important part of this overall process. Okay, so we talked about an example of the problem, right? What does ZN3 WWFL4 mean, right? But here's how that would get marked up, right? Here's an example of a set of haystack tags to describe that point, right? In red, we've got the point name in the BAS system. And we know there's a huge problem with point names, right? There's no standards. Everybody names the stuff different, et cetera. And you know what? We're never going to solve that problem. So don't try that. Okay? But we can come up with a uniform way to say what it means. So in green, a tag says this is a sensor as opposed to an output. This is discharge, right, of air or water. This is air. And we're measuring temperature in degrees Fahrenheit. Those describe what it is, right? But then we had one other tag, right? An association, the air handler ref or the schedule ref, another type of tag. And with those tags on a piece of data, software can automatically consume the data, analyze the data, present the data, help us accomplish our end goals, okay? So this is fundamental. In fact, if anybody's using software to do analytics and support their process, this is happening somewhere, either manually without a standard, right, a proprietary method for each and every product in the world, or hopefully more and more people are using this standard. Because one of the reasons is the Haystack organization, 501c, okay, and I have to make a disclaimer here. I am the executive director of that organization, and so I'm biased because it pays me exactly zero to do that, okay. But we started working with BACnet to bring this into the BACnet standard, because BACnet has very limited descriptors in the current version, but they see the need to move to what's called semantic modeling of data. That's the software term for all of this. So we've been working with them for over a year and a half now. Okay? Great. So we got that. But you know what? There's another challenge in normalizing data. You're taking it from all these different sources. What does it have? Different timestamps. This one was sampled this one was sampled this one was sampled this. And if I want to use that, interestingly enough, that can be a really complicated problem, but it's one software can solve, right? And this is just an example of a data grid showing that the timestamps are in the first column. You don't have to read them, you just get the idea. And this first column actually has a value at the first stamp. It doesn't have any more until down here. This one has a timestamp, has a value at every one of these, but didn't have it there. If I throw that at a computer, well, guess what? You can use functions, okay, to normalize that, because the end result is I want to look at a graph that aligns, correlates, and shows these data in relation to each other, because they may have a perfectly good reason for having separate timestamps. Like this might be change of value, right? This might be sampled every minute, et cetera. But the end result, you want to get there. And so historian functions, when you hear that word, historian functions are what are used to solve this part of the data normalization problem. Okay, so we know what the data means. We got the tags. We've taken care of this little messiness of timestamps being all over the place, right? Now we can see stuff in the data, and I could look at that and use my experience to go, oh, hey, there's a problem here, or this represents some type of performance issue or behavior. But we want to streamline that too, right? So let's talk about some of the things we do with just energy data, right? One of the most common things we want to do, support M&B and commissioning, is compare current to baselines, right? So that's one of the things we want to do. This chart simply shows, solid lines indicating actual and dotted lines indicating baselines because we want to compare against the baseline. And the software can make that really easy. Maybe we want to compare against a specific date. When did we make those ECMs? So I want before and after. That's good. But maybe I want to compare against other factors like previous year, right? Because I'm, 2017 is my baseline. I want, been putting in the ECMs. 2019 is my test year. I'm going to compare it against the baseline. Or maybe I'm doing something on a month-by-month basis. Or maybe there's other types of baselines that I want to look at as well. But the software makes it quick, easy to do the baseline analysis, right? Which will get us to the end result. And the other thing that this actually is an example of is one of the things the software can do is speed us on our way to the reports we need to deliver, because anything you see on the screen, you can put in a PowerPoint or a Word document or whatever and quickly get a nice report together, okay? But that's one step of using this data. But there's other things we want to do. Maybe we want to look at baselines in another view. This kind of just showing the different potential for showing results, right? This is called a delta baseline. So this is the 0 line there, right? And I'll walk out of frame on this guy. And we've got the 0 line, and we're seeing which sites are above and below. And this is actually a daily view over a period of time. I think it's 30 days, right? Which ones are above and below each and every day. They're color-coded to the site. Quick, easy way to see how a portfolio is working, right? I got a portfolio of buildings. These are above, these are below. And now I know how I'm doing against my baselines, right? So the tools help us support the baselining process, which is part of a lot of projects, okay? But then there's a whole additional factor we need to bring in because, we need to normalize this energy data because it can be affected by a lot of things, right? One of the most common is weather, right? So I want to normalize based on the weather because I want to compare my performance this year against pre-ECM years, and weather is a major factor, or it's one factor. Whether it's a major factor or not, we actually don't know, right? That's what normalization will tell us. We normalize against degree days, which I think everyone in the room knows is a very common, effective, and fuzzy way to measure energy because the way degree days are calculated. It helps. It's a great, quick first blush, but you may want to get more specific, right? But then there's other things. What if I have a portfolio? The building size would matter, right? Bigger building, more consumption, more KW, right? So if I'm looking at performance, I need to normalize for that. But then you want to go further, right? And these are common, I would say, weather and building size, but we like to get into things beyond that, right? We call it like the production factor. What are these buildings being used for, right? If it's a factory, that's kind of obvious example of production. Maybe we're making cans of paint and we want to actually track how much energy did the production line use? Oh, we used a lot less yesterday. Good. No, we didn't make any cans of paint yesterday, right? So we can bring in production data, right? So it's more than weather. We want to bring in other production factors. But there's lots of things. It could be unit production, like in a factory. It could be, here's an interesting example from fast food restaurants. You know what the production factor is there, how many meals they serve, and meals cost energy. So, what's the revenue per restaurant before I decide which restaurant in my chain, my franchise is more or less efficient, right? And then occupancy is important. Kind of the simplest example would be how much of my new office building is leased. That's common. Okay, that much leased out. I still got a quarter of the building hasn't been leased. But what if, increasingly there are cost-effective ways to actually measure real occupancy, right? So we're starting to see that as an additional form of data that can be brought into the analysis is actual measured occupancy, okay, if you've got the data, okay? And then there's other things that are specific to individual sites and projects, right? Universities don't go to the step of, in some cases, just an example, they go to the step of actually measuring occupancy with sensors, but what do they know? When the classes are scheduled. So this building is being used 7 hours today, that one's only being used 2 hours today. That's a really good measure because they'll measure it per hours of occupancy, okay? Didn't have to install any sensors for that, just have to get another type of data. What data is that? It's the Excel spreadsheet with all the class schedules on it. Okay, so we got to bring the Excel data in, right? Another form of data. Okay, so the tools help us do all that. Okay, and then when we're done, we can view our normalized data on multiple factors. That's really important. We don't want to normalize just against one. We want to be able to normalize against all those factors simultaneously. Okay, so let's continue on. Let's get more sophisticated in what we can do with our data and these tools, right? If we have an example where we say, okay, we're hitting high demand peaks right here, and you want to go try to figure out what could we do about that. Maybe we can reduce them, right? What's one of the first things you need to know? What equipment's running that's causing the demand peak, right? And that information is kind of out there, right? You could go and get the meter data. Maybe it's in the BAS, maybe it's separate. And then you could go and get into the BAS system, and hopefully they're recording things on history, and you could try to download all of that and say what's on when, and if you do this manually, you got a pretty good project in front of you. Well, that's where the magic of software comes in, because one of the things the software can do is automatically correlate equipment operations. So these horizontal bar graphs are showing when equipment is running. You can't read it all from there, but these are just pieces of equipment that are running, and it's correlated with our energy curves, right? So we can see, hey, when we hit that peak, this is what's running. Should it be running? No, we were supposed to soft start equipment. Let's go look at the schedule, or look at the specification of the control system. It was specified that we should soft start the second stage of equipment. I think we found a finding that needs to be investigated, because maybe nobody actually implemented the soft start routine, right? Okay, this quickly will lead us to understanding those types of issues in the commissioning of systems, right? By correlating equipment operation against our energy curves and doing it automatically. Again, I think everybody would agree, that sounds like a good thing to do, John, but if it's going to take you 3 weeks to do it, we can't charge the customer enough to do that. Well, what if it takes 300 milliseconds to do it? Hey, maybe we should do that, right? And that's software can do for us automatically, okay? All right, so let's talk about another one. I came from another session. I don't know if any of you went to the one Elliot did from Lawrence Berkeley Lab about the study about commissioning. Anybody go to that one? I was over there for that one. And it was a great session. And one of the things, somebody asked the question, are the savings you're showing money or energy? And the answer was, oh, it's energy, pure energy, okay? So I like to save energy. I'm socially responsible. I really like to save money, okay? And there's another factor that comes in here, because you know what? You can use more energy and spend less money if what? If you are on the right tariff rate. And one of the things we see in using data is that many customers don't realize that their energy consumption profile or usage costs way more on the tariff they're on, because they didn't understand and get on the right tariff, right? And as people do this, I bet a lot of people in the room, this is part of your business, is helping people understand what's your profile, what's your consumption, what are your peaks, what are your lows, what's the best rate. Well, that rate you picked 3 years ago, well, they got a whole bunch of new rates, it's kind of like the phone, like Verizon and stuff. I call them up, why is Paul paying less than me? Well, he signed up on this rate. You signed up on another one 3 years ago. You didn't tell me? Why would we tell you? Because then you'd pay us less, right? Okay. Well, it's a little more complicated with rates because they're complex, right? So how do we use software to help us? And the end result's really simple. In this chart up here, and again, you don't have to be able to read it to get the idea, the lines are my consumption and demand. The software will automatically take the rate information, calculate the cost for those exact periods of time, and overlay it together. Okay, draw your attention to this big tall bar graph in purple. We hit a $2,000 demand charge on that one day. My rate's got an 11-month ratchet. That one day, right? Cost me $24,000, right? The tools help us, number one, see that, right? And understand it so that we can assess different rates, right, on this. And you could do this manually, but A lot of work, a lot of time, a lot of cost, probably can't offer it cost effectively to the customer. And that's really what we're talking about. They were talking about the rate of return on, doing commissioning, right? And well, that's related to the cost. What if we can do it for half the cost? And that's what these tools are enabling us to do. Okay? So this is pretty interesting, being able to take what's called the tariff engine, add in all the charges, right? And the charges get complex. How many people here deal with looking at tariff rates and understand how to read the cryptic documents from a utility company? Okay, they're not simple, right? People ask me, oh, yeah, it's cool software. How much effort is it going to take to put my tariff rate in? I'm like, I have no idea. Get it from the utility company and see if you can read it first, right? That's step one, okay? Once you can read it and assess it, the software can make pretty quick work of the rest of it. All right, so that's another example. And all the different charges, I've got a number listed, right? Consumption charges, demand charges, time of use, both day and year, right? Service and equipment charges, distribution, generation, transmission, minimum contract prices, ratchets, ranges or blocks, right? Okay, and then other crazy stuff that people can negotiate, and then of course taxes, right? Those are all charges. And maybe you have the time, but our experience is almost nobody can take the time to manually try to calculate actual energy costs on interval data on all the possible charges. Well, software can do that pretty quick. Okay. All right, so that's tariff rates, and a little bigger example of seeing how they relate and breaking down your components with the stacked bar chart, right? The green here is consumption, and the red is demand, and et cetera. So another way we use the data. All right, so what we've been talking about up to this point are kind of the first ways that we use data in, I would say, the more classic deliverables from commissioning and M&B, right? Analysis, KPIs, rate analysis, et cetera. What analytics allows us to do is go to the next step, right? And move to automated detection of anomalies from the operating data. That's really what we want to go and talk about here. And a lot of times this is not part of commissioning in M&B. We're going to say we think it should be, and these tools, the same tools, can help us get there. So I like to start with that question when I talk to building owners. Do you know how your building systems operate? And as soon as somebody raises their hand, I go, really? Who is it that is, who's the guy who's responsible? Where is he in the room? Because if you're tracking this, there's somebody in the room who's responsible, and nobody ever raises their hand for that one, right? Okay. Because you know what? People say, well, no, I had an automation system. Oh, okay. There's a funny thing about computers, they'll do exactly what you tell them, including the wrong stuff day and day and day for 5 years, racking up hundreds of thousands of dollars of cost, right? So, this is not true. I have a computer-based building automation system. I open the telecom closet door, the lights are blinking, so everything's good, right? No, okay, right? Because were the control strategies well designed? How many consulting engineers in the room? Okay, so I know you wrote the control strategies right. It must be the next problem. Did they actually implement what you wrote down? Okay, maybe, maybe not. Okay, how about were the assumptions correct because you were doing the control spec and in the meantime somebody changed the equipment design, right? That never happens, right? But then there's this other problem with carbon-based life forms overriding things, right? Okay, always for a good reason, always for a good reason. The problem is, do they ever get put back, right? Back one of the projects we were on, we know it was for a good reason, but the override was really interesting. It was a 2x4, right? Didn't get enough fresh air. He says, I'm going to fix the stamper, disconnect the linkage, jam the 2x4 in there, and 100% fresh air for years, right? Right through the winter in New England. Really efficient. Okay, that stuff happens. We know that happens. That's what one-time commissioning detects if you get that level of walkthrough. But what if we can look at the data, and maybe we couldn't determine whether it was oak or pine, but we could probably tell there's something wrong with that damper, right? Because it's not behaving in a proper pattern of operation. You can't do this manually, but what the software can do is take you there, right? What we're talking about when we go to the analytic step, and we make a difference from that from the other things we were talking about, make a distinction, is software that can automatically look at the data to detect patterns, correlations, trends, relationships, anomalies, and go, that don't look right, and point it out to you, make it easy for you to see. That's not right. We've got a problem here. This happens to be the damper stuck open, right? And when it's happening, here are my temperatures, and here's my damper control signal, which is flatline. So if the damper control signal is flatline closed, how's the damper getting open? All right, something's happening, right? I believe this was the bird, actually, not the, okay? The big bird, louvers won't close, actual finding. Okay, who's gonna go up on the roof? It's probably not a part of their process that they check the roof every day or week, but the software can say, can't be happening, right? Okay. And what you end up with is continuous, and talking about moving from commissioning, retro commissioning to monitoring based or continuous process of commissioning, right? And you're taking the expert knowledge that the people in this room have because you do commissioning, but you're imparting it into the software so that it runs it automatically, looking for these patterns and anomalies. It also looks for stuff you didn't think of, right? Like, how could this be happening? So that's the role of analytics. All right, so analytics is good, but you know what? The reality is the available data will influence what you can do with analytics, right? But you can do a lot with even a really limited amount of data, okay? But you do have to assess that. But we like to bring up this example from a major customer that they only had 2 pieces of data. They had interval meter data for 65 buildings up and down the eastern seaboard, Class A suburban office buildings, the 4-story ones with the nice granite entries. And that's what they owned and operated. And they had invested in one thing, being able to get interval meter data. Okay, you got interval meter data from 65 buildings, okay? Who's looking at that every day? Okay, no hands go up. No hands went up in that organization, even though they're well run, because they're like, wow, I got my interval meter data, now what, right? And they had another piece of data that was really important. It was an Excel spreadsheet with all of the occupancy times they had committed to in all their leases for every floor of every one of those 65 buildings. And that's all they had. Well, with those 2 pieces of data, they were able to apply analytics and get return in weeks. And the reason is they were able to run analytics that looked at the schedule versus the consumption pattern and say, hey, wait a minute, this building we're committed to 7 a.m. to 7 p.m. Why are we starting up at 3 a.m. and running till 11 at night? Or why is there no fluctuation? Because you know what? Somebody overrode the systems, right? Because they moved in new tenants over the weekend or at night or whatever. All these good reasons that may never get corrected. But these are patterns. So after that, what happens? Something happens to the schedule. Portfolio managers immediately know and call Paul. Hey, schedules look a little weird in your building. What happened, right? Solve these problems before they go on for months or years. Okay. And then there's lots of things you can do with analytics. I know there's another session today, but there are common things. But I think one of the points of stress is all buildings are different, right? So you need the ability to do both things. You need the ability to apply common rules, but you need the ability for them to be programmable, because what could be a problem on one chiller plant could be exactly how this one was designed to run, right? And the last thing we need is false positives to waste time, because the whole goal here is let's be more efficient. But improper operation of economizers is one of the biggest issues, right? Simultaneous heating and cooling, right? Anybody ever detected simultaneous heating and cooling in a commissioning project? Yeah, okay. But it never happens, right? How could that possibly happen? Okay, like a heating valve won't close after the winter, so it's still passing hot water through, and now it's cooling mode. That's simultaneous. Everybody thinks, well, no, it means somebody turned on both at once. Not that simple. But that's a pattern that can be detected, right? Short cycling, long cycling. This unit's never shutting off. It's undersized, perhaps, for the load because they moved the walls in the building or something, right? Issues with zone or room thermostat deadbands, right? That same customer with the 65 buildings After they saw the value and got financial return from that quick, easy application analytics, then they went further and applied it further into the building. And they had a major problem in a couple of new buildings. Hot summer day, people are screaming, but they had actually connected and started analytics. And what they found was, and this was really interesting because the guy related it to me. He says, 25% of the zones in the building were absolutely miserably uncomfortable, and the other 75 were fine. To the point that I could be in my office and be perfectly comfortable, and 14 feet away, you were dying. How could this be? So what happens in a typical building when you get that type of crisis? Ladders. The ladders come out. The ceiling tiles go out. People are screaming, get this stuff fixed, right? You know what had happened? On 25% of the zones, the deadband got set backwards. As I like to say, you're a little warm? Oh, okay, well, we're gonna make you warmer, right? And simple, once they saw it, to go and fix them, right? Anyways, schedule's not followed. There's also a lot of talk about predictive rules. There's lots of predictive rules you can run. Predictive, for us, predictive really means the description of the rule and pattern it's detecting. Good example, loss of heat transfer efficiency. I expect 8 degrees of delta T across a coil. 6, 5, 4. Shoulder season day. Everybody's comfortable. No alarms. What is that telling us? The light at the end of the tunnel is a train. You may be comfortable today, but you're not going to be as soon as the heat wave comes through. Those are predictive. All right. And here's an example, right? Of detecting damper won't modulate, which could be due to temperature sensor problems, detecting bad sensors. You can detect bad sensors, right? Economizer operating when it shouldn't be, or not operating when it should, both of which there's money there, right? Energy. Greater ventilation than needed, inadequate. What do you need for data, right? That's a quick question people ask is, I want to do this analytic stuff. What do I need for data? Well, you need mixed air, return air, outdoor, damper control signals, on-off status, right? And you know what? You can measure it at a lot of different intervals. The more data you have, the better, but you can pick up problems like this with hourly data. So, anyways, and what does it look like? And this gets into a key part of kind of the end result of analytics is we have to present results to operators or engineers or whoever's responsible in a way that helps them. And this is a big area of development by all the companies involved in the analytics is, how do we communicate information to human beings as intuitively, as effectively as possible? One of the techniques that we use is we call them, timelines. And what we're seeing here are not on-off equipment timelines, we're seeing fault timelines. KW exceeding target, when it began, when it ended, lights on during unoccupied period, short cycling of equipment, damper stuck open when it shouldn't be, right? And actually showing, here's the pattern I found in the data. I found right here that your damper was open when it shouldn't be, right? I compared the control signal, 0, against the differential between mixed air and return air, and you get a differential that can't possibly happen unless outside air is coming through that damper. So you think it's closed? The signal says it's closed? That's nice. It's not closed, okay? And how do we convey that to operators and people responsible as quickly as possible so that they can see that with help and information? And that's a big area here. You see constant advances in presenting results. Okay, like this, another way to do it, right? The timelines are great for those of us who know equipment systems and we want to know things like, wow, that happened at 3:42 p.m. It lasted for 17 minutes. Came back again an hour and 3 minutes later, right? We're trying to figure the equipment out. And then there's these people who manage the buildings and they just go, hey, what kind of problems am I having? How big are they? How much they costing me? Give me something simple. That's the example of a bubble chart showing either cost or duration, magnitude oriented of problems. Each cell is a problem on a piece of equipment or a site. Because they have a different, that manager level person has a different interest in data. All right. So then there's other things that are used and analytics can solve for us, which is calculating key performance indicators. And maybe we should have put this one a little earlier, but that's part of most projects, assessing KPIs. Well, guess what? If the software has the data and you define the KPI once, then it just calculates them. I need the KPIs today, John. Click. Right? You got them always there. And the KPIs can go to anything you can express with math, right? I mean, there's some common ones. Maybe we care about KW range. If you're familiar with donut charts, the inner circle is the minimum, the outer circle is the maximum, and the range shows us the range, right? But there's other types of KPIs that are really important, right? Maybe we want to have what's called a delta KPI. We want to take our KWH consumption per degree day, but we want to compare it to the previous year, and that's what this is showing. These show whether I'm below or above the previous year. And with the software, we can easily set up lots of KPIs and get into more sophistication than we might if we were doing this manually, right? And it serves to help us track performance in our buildings. And they can be, sum-based, range-based, range of sums, average, delta, all the common math functions. All right. So one of the things that comes up a lot is people say, well, wait a minute. I have that automation system, and we can program alarms in it. So why are analytics different from alarms? And so we're going to spend just a little bit of time on that because there's very distinct differences. And I'll start by saying, doesn't mean one's bad. You need both, right? Okay? Not alarms are bad and analytics are good, or the other way around. They're two different things, actually. And I thought this is a great example. An alarm, you're on the gurney in the AR, and people are putting tubes in you. That's an alarm. Analytics are the yearly appointment where, John, you should lose a few pounds, your blood pressure's going up a little bit, your blood sugar's getting high. That's analytics. Okay? Let's apply that to buildings, right? Now, there's some other distinctions too, right? I don't want any alarms, basically, and if I can detect those conditions happening ahead of time, maybe I can avoid them. Right? But there's others. One of the things about alarms and control systems is by defining an alarm, it means you knew ahead of time to do it. Well, there's a lot of things we know ahead of time, but you know what? Buildings are complex. We learn things about it. Analytics, you can add at any time. I can say, we ought to look for damper stuck open, implement that this moment, and you know what the analytics will do? They'll run back in time over all the available data and go, hey, you know what, John? You had that problem last August. Okay? Alarms don't do that. Time's gone by, the alarms are gone by, right? So that's a key. But this other thing, if you had to know them ahead of time, and what happens with specifications? Oh, we have a list of basic alarms we want in the system, and of course, they get implemented. That was a joke. Okay. And even if they do, it's limited based on what was known or assumed at that time and what was negotiated in the controls. Analytics are about finding deeper relationships, right? Things that you couldn't have foreseen in the design, one-off, first-of-a-kind chill plane. We're going to do it this way this time. You don't know all the possible behaviors that thing is going to experience, right? The other thing is when you put alarms in the controller, they deal with stuff the controller senses, right? Its inputs, its outputs. Well, we've already talked about all these other types of data that we want to bring together. It's not in the control system. So alarms can't help us with KPIs related to data outside the control system. Alarms couldn't help that guy with the 65 buildings, right? Because he had a very modern control system, but the controllers didn't have a slot on them to insert an Excel spreadsheet, right? Because he needed the occupancy data. It's not in the control system, right? The occupancy schedules he committed to in the lease. It's not in the controller. So you got to think beyond just the temperature sensor, okay? And there's lots of other things. I want to do an analysis based on age of building. We had a customer do that. And they were surprised to find out their older buildings perform better than the new ones. And in fact, you're shaking your head, right? And they went away. I didn't get to talk to them for a while because they weren't too happy to find that out. And they were off talking to somebody else about the problem, not me. Okay, but equipment type, different brand of equipment, right? Age of equipment, material. We have 3 different types of construction. Which building performs better? These aren't controller data oriented analytics. Right? Okay. The other thing is this whole idea of most alarms, pretty strong, a pretty verifiable assumption. It's now. You're over your limit. Great. You had a heart attack. Great. I would have liked to know my cholesterol was coming, right? The other thing is alarms are in the control system and they get to touch them. So how many people in here as part of your commissioning work are actually given the ability to go in and change control program sequences. Maybe you didn't hear me. I didn't see any hands come up. Right? You can't, right? Because you do, you touch it. It's kind of like in the China shop. You touch it, you own it, right? You can't touch the control system, right? So it's not a good place to do advanced analytics. Great place for alarms, but it's not a good place, right? And of course, cascading alarms, right? Well, analytics can sort that out and see that this is the issue. Yeah, you may have 100 alarms, but this is the issue. Okay. And, just another way to present it, let's talk about a different type of tool that's used extensively, and I imagine a lot of you do, just energy analysis tools. Again, not one's bad or good. You have energy analysis tools, and if you do, you can probably get a chart like this. Yep, here's our profile, that's our energy use, very useful. But what it doesn't answer is what equipment's causing it. That's analytics, right? Which speeds you on your way to recommending what should be done to help them get on a lower, reduce the demand and get on a better tariff rate, right? These are the differences between analysis tools and analysis tools and automated analytics. Okay. But here's what I really came here to tell you about. Okay. After all of this great, telling you how great this stuff is, analytics actually don't save any money. Why did I come here, right? Well, this is an interesting thing, and we bring this out because what we find in the construction and the building environment industry, everybody's fixated on things they can buy, capital equipment. I put it in, I get lower energy. Analytics don't save any money. Why? Okay? Because to get value, you got to do something. If the analytics find a problem, somebody has to go correct the problem. And if they don't correct the problem, nobody saves any money. And this is actually an interesting dynamic because a lot of organizations aren't prepared for this, right? And the way we test that is this, walk into a building owner and say, I don't have any software, right? You're old enough to get this joke. We hired Karnak when Johnny Carson retired. Remember Karnak? This guy, And we're going to just fly Karnak out to your building. He's just going to come into your building. You have 100 problems. Here they are. Now what? Can you fix them? Maybe. What if they require capital? You already committed to that capital budget, and that CFO hates when you come back to ask for more, right? Okay. Or you know what? You committed to a guaranteed maintenance program that has fixed boundaries on what they fix, and you got to go, hey, you know how I saved you 10% on maintenance? Well, we got a little problem here, right? We've seen situations where organizations struggle to get the money to fix a problem that has a 1-month payback. Why? We all know how budgets work. So you got to think about that. The last mile, you got to fix up. And then this factor. Analytics aren't a thing. They're not a physical thing, right? And again, we bring this up, this may sound obvious, but this is what owners, operators, engineers are facing. So many other things at their doorstep are physical things like LED light bulb. Buy light bulb, screw light bulb in, calculate savings. It's great. Well, guess what? Analytics aren't that, right? They give us information, they find issues, we have to act on those issues, and it's not possible to calculate the exact savings ahead of time, all right? And that presents a really interesting challenge, right? Hey, I want to apply analytics to your bill. It sounds really interesting, John. How much are you going to save me? I don't know. Why? What are you insane? Get out of my office, right? Well, there's a problem. Analytics are about finding what's wrong. Until we find out what's wrong, we can't tell you how much you're going to save. It's not good enough. Yeah, okay. I'll make you a deal. I'll guarantee your savings under one condition. You guarantee you fix everything I find. And people go, whoa, 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 whoa. Now wait a minute. We can't do that. Why not? Because I don't know what you're going to find. Exactly. Okay? And that's something really important about as we as an industry move into using these tools. This is a real significant issue. We're joking about it. This is really a serious issue for organizations to get their head around. Okay? They're a tool to help us understand where the deficiencies are. Okay, so how do we deal with that? Oh, these are the questions. Those are your follow-up questions. The way we deal with it is we suggest people start small and simple. Like that guy who had 2 pieces of data, right? Interval meter data, even if it was only for one building and a schedule, use analytics to see, what does this tell me? Maybe it tells you something you can immediately save money on, get a rapid payback, and say, you know what, we ought to take another step with this. One of the things we say is analytics is an exploratory tool, right? Not a capital guaranteed savings. And you got to treat it like that. And that means you got to treat the whole project design. You got to treat the whole attitude of getting management or your customer on board with it. We want to apply these tools to explore what's happening in your building. Yeah, I can point to lots of case studies where there's great results, right? There's lots of validation out there. But the reality is, you know, these are a tool, but they're going to give us information, and then we're going to have to assess, you know what, you found a great problem, but I don't have the money to fix that right now. Okay. Do I get credit for finding that for you, though? Right? Because maybe it'll affect next year's budget. Maybe it'll finally give you the tools you need to have that proper argument, debate, presentation with upper management on the budget you need to run your buildings right. Right? Information helps you justify expenses, prioritize expenses, etc. This is the world of using data, and it's different than the other types of things and most people in the industry have been doing. So with that, that's what I had to convey today.